Hello and welcome to our first section for chapter 6. We're going to talk about discrete and continuous random variables. All right, so we're going to talk about discrete random variables, mean expected values of a discrete random variable, standard deviation and variance of discrete random variables, and then we're going to talk about continuous random variables. All right, so random variable is a variable that takes a numeric value. It describes the outcome of some chance process. So for example, flipping heads, rolling 2 die whose sum is 7. Those are two random variables. So the outcome would be flipping heads, and then the outcome would be a sum of 7. So 4 and 3, 3 and 4 would bring you a sum of 7 for 2 die. Probability distribution we've talked about. Probability distribution of random variables gives its possible values and their probabilities. So flipping a heads is 0.5. Flipping a tails would be then, as part of the sample space, 0.5. Rolling a 7 would be 1 out of 6. Also, there's 1, 6, and 6, 1, by the way, for rolling a 7. And then you can talk about the probability distribution for rolling something other than a 7. So probability of rolling a 6, probability of rolling a 3, probability of rolling a 4, probability of rolling a 2. So that would be a probability distribution. All right, so discrete random variables and their probability distributions. A discrete random variable x takes a fixed set of possible values with gaps between. So the value x, x1, x2, x3, so the probability of rolling a 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And then the probability outcome. The probabilities must satisfy 2 requirements, and we talked about this before in chapter 5. So again, the probabilities have to satisfy 2 requirements. Probability has to be between 0 and 1. This should be inclusive of 0 and 1. And the sum of all probabilities is equal to 1. If you want to find out the probability of each of the events, then you can sum the probabilities of each of the discrete values to find the overall probability. All right. So meaning if you want to find the probability of x1 and x2, then you'd add x1, p1 and p2. All right, so moving on. This is an example. This is a probability distribution of AP stats grades, where 0 is an F and 4 is an A. So I have F, D, C, B, and A. And then we're going to find what the probability is of scoring a C or better, and what the probability is of scoring a D or worse. So for C or better, we'd say probability of X. In this case, we define the value of X. So the probability of X is greater than or equal to 2, C or better. Would be probability of 2 plus a probability of 3 plus a probability of 4. That's 0.2 plus 0.42 plus 0.26. That's equal to 0.88. And what's the probability of scoring a D or worse? So I have probability of 0 plus a probability of 1 would be the probability of X is less than or equal to 1. As you would write this mathematically, that's 0.02 plus 0.10, that equals 0.12. All right, so that brings us to our first homework problem, 6.1.1. Below is a table that describes the probability distribution of goals in a game for teams in the National Hockey League. Define the random variable x as being the number of goals scored by a randomly selected team in a random game. Show the probability distribution for x is legitimate. Then make a distribution of the histogram of the distribution. Describe what you see. And finally, what is the probability that the number of goals scored by a randomly selected game is at least 6? So I'm going to leave this up for a moment. and then I'm going to move on. All right, so moving on. So next thing that we want to talk about is the mean of a discrete random variable, otherwise called the expected value of a discrete random variable. And this is where I think there's a lot of benefit, not only in statistics and probability. I'd love to talk about expected value. So there will be some opportunities for more expected value work outside of the class and some real life applications. So let's talk about the mean or expected value of a discrete random variable. Really what this is a probability weighted outcome of some specific outcome. So let's take an example. If we flip a coin and it ends up heads, you're going to win $50. If it comes up tails, you lose $30. What is the expected value of flipping the coin? All right, so what we want to do is we want to multiply the probability of the outcome times the weight of the outcome, whatever that might be. Or we could say the value of the outcome. So in this case, we're going to multiply the probability of flipping a heads, which is 0.5, times the weight or the value of the outcome, which is $50. And then we're going to add that to another weighted outcome, probability weighted outcome. So flipping a tails, again, is 0.5 times the value or weight is negative 30. So we end up with 0.5 times 50 or $25 plus 0.5 times negative 30, which is minus $15. And that is equal to $10. So your expected value for flipping this coin is $10. If you were to flip it an infinite number of times, then you would end up with an average or a mean value of $10 per flip. So now when we consider certain events, and betting is a great way to consider expected value, we are thinking about how much we would pay in order to have the opportunity to flip this coin given these outcomes. And we would be willing to pay anything up to $10, but beyond $10, this is a losing proposition for us. And so if you think about the casinos, what they end up doing is they have these probability weighted outcomes where the expected value is negative, but there are outcomes that are certainly positive. So the enticement is to win those large outcomes. But overall, as the number of games progresses, they end up with an expected value outcome that ends up being in the limit, the value that they earn for each event. All right, so basically what this says is if you flip a coin an infinite number of times, then your average gain, the expected value from each flip is $10. All right, so this is an example I'm going to use for class. You roll a die at a local gambling casino. If you roll a 1, 2, or 3, you win $20. If you roll a 4, you lose 50, and if you roll a 5 or 6, you lose 5. What's the expected value of the roll of the die? All right, so here we go. Probability of 1, 2, or 3 is 3 over 6 times the weighted value, $20, plus 1 over 6, the probability of rolling a 4, times the weighted value, negative $50, plus 1 over 3, the probability of rolling a 5 or a 6, times negative 5. So that leaves us with 10 plus negative 25 over 3 plus negative 5 over 3, which is equal to 0. So the expected value of the roll of the die is 0. All right, which means that if we were to play anything for this game, then whatever we contribute to the casino is their expected outcome per event. All right, so this brings us to homework 6.1.2. If the sum of two rolled die is 8 or more, you win $2. If not, you lose $1. What's the expected value of the game? All right, so I'm going to leave this up for a moment and let you figure out and write down these values, and then I'm going to move on. All right, so let's talk about standard deviation and variance of a discrete random variable. All right, so mean expected value, that's something we get from the probability weighted outcomes, right? So we multiply whatever the probability is times the value of that event. So x1 times p1 plus x2 times p2, etc. That's the expected or the mean value of an event. The variance then is going to be the sum of the squared differences between the value minus the mean value times the probability. All right. So the variance is equal to the sum of the squared differences of the value minus the mean value, then times the probability of that event. And the standard deviation is just the square root of the variance. All right, so let's take an example. Below is a probability distribution of APGAR scores for babies. So APGAR scores are scores that doctors give to babies when they are born. It's a way of them assessing their health. Say 0 is not good, 10 is very good. And so we're going to calculate the mean expected value of the APGAR score. So we're just multiplying x1 times p1 and then summing the total values. So you can see the expected value or the mean value of the APGAR score is going to be 8.128. All right, this brings us to our third homework problem. I'm going to have you write this down. Calculate the mean or expected value of goals in an NHL for a given team. All right, so this is the probability distribution. So 0 goals for a team, 1, 2, 3, 4 through 9, and the probability that they score those number of goals. So what's the mean expected value or mean expected number of goals for an NHL team in a given game? All right, so I'm going to move on in a moment. All right, so the last thing that we want to talk about is continuous random variables. So a continuous random variable is a random variable which encompasses an infinite number of possible outcomes. A random variable x that takes all values of an interval of the numbers. So not discrete numbers like we had before, APGAR score 0 through 10, right, or number of goals 0 through 9. We have some continuous list of outcomes. So the probability of any event is the area then under the density curve and above the values of x that make up the event. So let's see if we can put some context to this. So we're back to our normal distribution. The figure above shows a normal distribution of heights for women. The mean height for a woman is 64 inches, with a standard deviation of 2.7 inches. What is the probability that a randomly selected woman will have a height between 68 and 70 inches? All right, so here we have this area here. What's this probability? If we consider now this curve, the area under the curve equal to 1, we're back to our understanding of a probability that's between 0 and 1, being just this area in purple. All right, so we take the z-score for 68 inches, the z-score for 70 inches. We find the area between 1.48 z-score and 2.22 z-score by looking at the table using our calculator. We show that that 2.22 standard deviations is equivalent to the score of or the height of 70, and 1.48 is for the height of 68. And so then we see that 2.22 represents 98.68% of the values below 70, and 93.06% represents the total area underneath the curve below 1.48. So we subtract what's to the left of 68 from what's to the left of 70, and we end up with 5.62%. And so 0.0562 is the probability that a randomly selected woman will have a height between 68 and 70 inches, so about 5.6%. All right, so this brings us to homework 6.1.4. You take a moment to write this down. And then we're going to end here. Thanks very much for joining us, or joining me. and we'll see you next time when we continue our discussion about probabilities.